Everyone, and welcome. Today we are diving into a truly fascinating explainer brought to us by Dr. Christophe DeLong and Connexa Formation. We're going to be exploring the core theme of neuroplasticity, that is the brain's absolutely extraordinary ability to rebuild, reorganize, and adapt itself, especially after an injury. And to make the complex biology incredibly clear, we're going to use a brilliant metaphor throughout this presentation. We're going to look at the brain as a massive mountain landscape, and we'll look at learning or healing as the literal act of forging new trails.
So here is our trail map for today's expedition. We're covering everything from the trail of rehabilitation and the brain's core rules to paving the new path, the massive cost of reconstruction, fertilizing your brain, and finally, how all of this applies way beyond just the initial injury. All right, let's just jump right into Section 1, the trail of rehabilitation. To really understand neuroplasticity, we have to look at the actual terrain of a brain injury. Picture a nerve injury as a massive, unexpected landslide that completely wipes out the main trail up a mountain. Now, the mountain itself isn't impassable, but that easy, well-worn route, it's totally gone. To keep moving forward, you have to create a deviation. And at first, you're forced to literally bushwhack through thick, waist-high grass and rough brush. Every single step requires a huge conscious physical effort. It's exhausting, the fatigue sets in incredibly fast, and honestly, the path forward feels very uncertain. Well, that is exactly what the first days of neurological rehabilitation feel like.
But here's the thing you have to remember. Neuroplasticity is never automatic. It doesn't just happen because time passes. Just like a crew of lumberjacks actively cutting through fallen logs to clear a blocked trail, neuroplasticity requires conscious, deliberate, and physically exhausting effort. Every attempted movement, every single rehab exercise, is basically a swing of the axe. It's a footstep marking the new ground. Without that deliberate effort, the biological construction site stays completely shut down.
Because of that reality, there are three absolute pillars of neural reconstruction. First, active effort, which we just saw. Second, daily repetition. A single hike through tall grass only leaves a temporary trace, right? It's the daily repetitive passage that eventually flattens the grass, packs down the dirt, and turns a fragile little trace into a solid communication pathway. And finally, grounded hope. The brain is incredibly resourceful. It is always looking for a detour. Understanding this gives patients real, scientifically grounded hope that progression is absolutely possible, even with complex injuries. Moving right along to Section 2, the brain's rule. Let's look at the fundamental biological rules that govern how this new path actually survives. You know when you clear a path in your yard, completely ignore it for a month, and come back to find it entirely overgrown? Well, the brain does the exact same thing. It operates on a very strict use it or lose it policy, which is known, biologically, as synaptic depression. If you stop walking the new trail, like if you stop rehab way too early, the brain actually removes the receptors and pulls back those connections. The map in your brain literally shrinks. This is exactly why consistency is everything. Skipping rehab causes an invisible, completely silent regression. The weeds literally grow back. Now, there is a critical distinction we need to make here between a dead neuron and a dead function. Yes, when a neuron dies, it is permanently lost, but the function it performed, something like lifting your arm, doesn't belong to just one single neuron. It belongs to a whole network. If the main bridge goes out, the brain essentially hires local guides. It recruits neighboring healthy neurons to take over the job. They learn to compensate and literally guide the signal around the damage. So how do those local guides actually connect? It's through a process called sprouting. The surviving neurons literally reach out. They grow brand new branches, which are called dendrites, and these act like tiny new bridges spanning across the landslide area to reestablish contact with other networks. It is a slow process. They have to detect the missing partners, physically grow, and form new synapses, but it absolutely proves that the brain continues its reconstruction work months or even years after the initial injury. Okay, Section 3, paving the new path. We know how the fragile dirt path is formed. But how does the brain turn that exhausting dirt trace into a high-speed highway? The secret here is myelination. Myelin is an insulating sheath the brain wraps around these new neural pathways. Think of it as basically pouring asphalt on a dirt road. In Step 1, the uncertain trace, there is no myelin. The signal is slow, causing massive cognitive fatigue and clumsy movements. In Step 2, the beaten path, the brain starts wrapping the wires. Movements get smoother, a little less taxing. And finally, in Step 3, the paved road, the pathway is fully myelinated. That signal travels at lightning speed, and the movement becomes completely automatic. You don't even have to think about it anymore. Listen, if you take one thing away from this, remember this crucial point. Fatigue always precedes automaticity. I really want to speak directly to anyone going through rehabilitation right now. The intense cognitive and physical exhaustion you feel in those early weeks is not a failure. It is absolutely not a sign that you aren't healing. Actually, is the exact opposite. That fatigue is the biological proof that your brain is actively working overtime to pave the road.
Which brings us perfectly into Section 4, the cost of reconstruction. Let's look at the hard numbers to understand exactly why recovery feels so slow.
Get this, the brain consumes a staggering 20% of our body's total energy every single day. Just operating normally is incredibly expensive. But when the brain goes into full-on construction mode to sprout new dendrites, rewire local guides, and synthesize myelin, that energy demand skyrockets. Structural reconstruction is an unbelievably expensive investment for your body.
Now contrast that massive energy drain with this number, 2%. The brain makes up only about 2% of our total body weight. Crazy, right? This tiny organ is monopolizing a fifth of your fuel. Your body has to carefully balance the massive energy needs of this biological construction site while also keeping the rest of your vital organs running smoothly.
And here is perhaps the most sobering reality check of all. Just 1 to 2 millimeters. That is the daily growth rate of a new axon. This perfectly explains the huge disconnect patients feel. You put in hours of exhausting effort today, but you don't magically feel better tomorrow because the biological cable only grew by 1 millimeter. The slowness isn't a defect, it's just the physical reality of building cellular structures completely from scratch. Knowing how slow and expensive this process is, let's look at Section 5, fertilizing your brain. Let's talk about optimizing that internal ecosystem. You can literally fertilize your plasticity by optimizing your environment. First up, sleep. During the day, you walk the path, but it's only at night while you sleep that the brain actually lays down the myelin to pave it. Second, manage your stress. High levels of cortisol act like an herbicide, literally blocking new roots from growing. You also want to embrace novelty and learning, which releases a miracle growth hormone called BDNF. Throw in a diet rich in omega-3s, rich sensory stimulation, and even motor visualization, where just imagining a movement activates the exact same neural networks without the physical fatigue.
Finally, as we reach the summit of today's explainer, let's look at Section 6, Beyond the Injury.
This brilliantly illustrates the true everyday power of neuroplasticity. The hiking trail metaphor? It applies perfectly to everything your brain processes. If you've lived through a prolonged stressful situation, your brain paved a multi-lane highway of anxiety just to help you survive. But now you can actively trace new, calmer paths. The exact same goes for learning a new language, mastering an instrument, or breaking negative repetitive thought patterns. It's all about leaving the wide, easy highway of an old habit and stepping off into the tall grass to forge a completely new reaction.
But we have to separate willpower from biology here. Intention, your motivation, is what brings the hikers to the edge of the cliff. It's the decision to start. But you cannot draw a trail into existence just by wishing for it. Only repetitive physical action, the literal footsteps crushing the grass day after day, can actually transform the biological terrain of your brain.
So neuroplasticity isn't magic, and it certainly isn't instantaneous. It is a slow, costly biological construction site. But it is also deeply, profoundly optimistic because it proves that no mountain in your mind is immutable. Every single effort leaves a trace. So, keeping that in mind, what new trail will you forge today? Thank you so much for exploring this fascinating topic with me, derived directly from the wonderful insights of Dr. Christophe DeLong and Kinexa Formation. We will see you next time.